Hello, everyone. I'm here to talk to you about test-driven infrastructure and how to bring tranquility to your infrastructure with testing. My name is Arthur Maltson. You can follow me on Twitter and GitHub there. So today I'm going to talk to you about a problem that plagues both large companies, like big financials, and small hip startups in Liberty Village. And that problem is untested infrastructure. So what are the symptoms of untested infrastructure? Well, do you find yourself crossing your fingers before you deploy to production? Are you getting paged late at night? Do you have some stability issues? And does that automation that you put together, does it have some surprising side effects? Well, if you talk to your friendly neighborhood DevOps unicorn, they might tell you about something called test-driven infrastructure. And you might be wondering, well, what is this test-driven infrastructure? I think we have to go back a bit, provide some context where this comes from. This comes from a concept in software development called test-driven development. And test-driven development has been shown in the software development world to produce better code that's more stable and easier to maintain. So if you listen to these crazy DevOps unicorns, what might you expect if you start practicing test-driven infrastructure? Well, you might find you have extreme confidence in your code. You might also find that your infrastructure is very stable. And you'll have general operational and developer happiness. So what does it take to get there? Well, it's not free. There's definitely a lot of tools involved. So let's enumerate them. First, you got to start off with a configuration management system. Now, that can be Chef. That's what the examples here will be in. But really, it can be anything. It can be Ansible. It can be Puppet. Pick your flavor of the month configuration management system. It can even be hand-rolled bash scripts. That's totally cool. But you probably want a configuration management system to start with. And in our example, we're going to be setting up Redis. So I'm using Chef as the example here. This is really all you're going to see, right? We're going to pull in the Redis IO Cookbook that exists. It's a community cookbook that's open source, and we're just going to start using it. So the other tool that we're going to need is Test Kitchen. So Test Kitchen is really the workhorse when we talk about test-driven infrastructure. And the thing that's really cool with Test Kitchen is massively pluggable. So with Test Kitchen, you can run your tests on any driver. So that means Docker, which is going to be our example. But you could use Vagrant. You can use Amazon Web Services. It's up to you. You can communicate with that Vagrant box over SSH, or if you're testing Windows, WinRM. You can provision those Test Kitchen containers, the things that you're testing, with anything, Chef, Puppet, Ansible, as I mentioned. And you can write your tests in something called ServerSpec, which is what we're going to go over today. But you could also, if you want to write your tests in PowerShell, then Pester's your friend. If you really like writing tests in Bash, you can do it with bats. And finally, we can run all of these tests on multiple infrastructures. So this is the power of Test Kitchen. You just pick which platform you want to do it in. So CentOS, Ubuntu, Windows, it's totally up to you. And the 3 commands of interest that we're going to be using here with Test Kitchen is kitchen login. So that means log into the container that we're testing. Kitchen converge, which in the Chef world, that means take the server in its empty state and bring it into the state that you told it to be in. And converge, again, will work with Ansible and SaltStack and whatever. And verify. And verify is the step in Test Kitchen that runs the tests. So anytime we're going to be making changes to the cookbook, we're going to have to run a kitchen converge to get the machine back into the state that we expect it to be in. And finally, the other tool that we're going to be using is ServerSpec, and ServerSpec is an extension to RSpec, which is a Ruby testing framework. And ServerSpec is specifically built to test servers and check the state of those servers. So what's really cool about ServerSpec is it provides a high-level RSpec language and DSL for testing underlying operating system features. So let's see, what does the ServerSpec code look like? So if we wanted to test if a certain port is being listened to on the system, you really just have to do something like this. Describe port 80 and make sure that it's being listened to on that port. And if you're using UDP or TCP version 6, again, all of that's customizable with ServerSpec. If you want to check if a service is running, right? So ideally, when you're installing something on the system, if the system reboots, that thing you installed starts back up. So you want to have a service. If you want to check if the service is there and it's enabled, again, this is how you do it in ServerSpec. If you want to know, does the system have a user on it? So I'm creating a user. I want to make sure that the user is there. Again, you just say describe user, and it should exist, right? So very English-like syntax. And these are all the built-in resources in ServerSpec. But say you want to do something that just ServerSpec doesn't provide. Well, ServerSpec provides kind of the ultimate command that you can execute called command, which is basically, this is your backdoor to run any command on the operating system and then inspect its standard output, its standard error, and its exit status. And finally, the last tool in our toolbox is going to be Docker. So, of course, no DevOps presentation is remiss in mentioning Docker. But in our particular use case, we're using Docker in an isolated manner. We're using it for testing only. And it's really the perfect use case here because we get massive performance gains. And we'll go into those shortly. So to use Docker inside of Test Kitchen has a kitchen YAML file, which describes how to run your test suite and which platforms to use, right? So I mentioned platforms, CentOS, Ubuntu. We're going to start with CentOS. What your provisioner is, so Chef in this case. And finally, what's your driver? And so this is, you just really put this line, driver name, Docker instead of Vagrant, and you're using Docker. You just have to make sure to install the kitchen Docker gem. So I talked about the performance gains. Well, let's quantify those. So with Vagrant, in our particular example, you have the overhead of spinning up an entire operating system, waiting for it to boot up before you can actually start to run your tests. So a simple and empty Vagrant box is going to take you 3.5 minutes to do a full verification cycle. If we just change that one line from Vagrant to Docker, we're now at 2 minutes and 30 seconds. So we've dropped an entire minute plus from our feedback cycle. And the feedback cycle is very important when doing test-driven infrastructure, just as it is in test-driven development. You want to make a change, and you want to see the test pass or fail as quickly as possible. And finally, the example that I'm going to be using is a Docker image that has some caching built inside of it. So we already installed the Chef, the Chef client. We actually download Redis prior. So you can actually, if you want faster feedback cycles, you can build custom Docker images and start using those for your testing. And in my case, I'm doing this because I don't want to rely on the internet. So we have all our tools in place. We got our safety goggles on. And what does the process look like, right? So we want to start to practice this test-driven infrastructure. So before we do that, let's look at what does test-driven development look like. Well, first, you write a failing test, then you make it pass, and then you refactor, right? So the refactor part, that's definitely a very important part. You want to write, you want to get the test passing as quickly as possible, and then you want to make the code easier to maintain, and that's the refactoring part. And having that test bed gives you the confidence to do that refactoring. And personally, I'm not very religious about whether you write your test first or you write the production code first. It doesn't matter as long as they kind of come together. So how does this work in a test-driven infrastructure world? Well, first you write a failing ServerSpec test. Then you write the recipe to make that test pass, or bash script or playbook, whatever it is. And then you can refactor. And the refactor part for test-driven infrastructure is not as big because, honestly, the code is fairly straightforward. But let's say you want to switch from Chef to Puppet or whatever the case may be. Having that test bed tells you this is the state I expect the system to be in. And if I've switched a configuration management system, I still have the confidence that whatever it is that I wrote still works on that system. So let's see it in action, right? Let's do some live coding. And we're going to write a cookbook that installs Redis, but we're going to do it in a test-driven fashion. So I'm just going to record the screen. Forgot to do this earlier. All right. So we're in a very standard chef cookbook. Again, this is chef specific, but really all I want to show you is that it's just regular chef code. If we take a look at the recipe, you can see it does nothing right now, right? So it's kind of an empty cookbook. If we take a look at the test integration, you can see we're not testing anything just yet. And finally, if we do a kitchen login, just to show you that I'm not hoodwinking you, there's actually no Redis on this system. We can check the process. Right, there's no Redis there. So, kind of empty CentOS system, right? If we do yum help, you can see the yum command is there, right? So this is a regular CentOS Docker image. Yes, I'm on a Mac, right? But that's the beauty of Docker, right? So I can do that really easily. So let's describe what we want this Redis to look like, right? So let's test. Let's check our. Let's change our test. You can see right here. This is the link to all the ServerSpec resources that you can use. But let's make a change. So the first thing we want, like any good Linux system, you want the thing that you're installing to run as a separate user, not as root, right? Standard security practices. So let's make sure that we have a Redis user. Oops. And that Redis user should exist, right? So again, I'm kind of speaking English, and that's kind of how I'm writing it. The other thing is we want the Redis database to live on the file system, right? So we're going to describe a file, and this is where it gets installed by default. So var lib Redis, and it should be a directory. Oops. Should be a directory. So that's our base test, just to make sure that Redis is actually installed on the system. So let's run a kitchen verify, right? So write a failing test. Let's run that test and see it fail. And see right here, you can see this is the really cool part of ServerSpec. Even though we said make sure that the Redis user exists, it logs into the system and runs the ID command, which is a Linux command, to see is the user there. And you can see that that failed. The same thing with the directory. It just tests that it's a directory -d. So these are your standard shell commands running inside of that CentOS Docker image. All right. Well, let's make this test pass. So as I said, we're going to use the Redis IO Cookbook that lives on Supermarket. So again, that's kind of chef-specific stuff, but you get the gist, right? So we're going to say depend on Redis IO to be there. And we're going to do one little hack. This is, again, to make this work offline. I'm going to tell Redis IO that, hey, when you go to install, look in file temp Redis, right? So this is where in my custom Docker container that I created, this is where I had downloaded Redis prior, because we don't want to go to the internet and depend on that, right? So that's just the one tweak that I have to make. And finally, we have to change the recipe, right? So we said include the cookbook, but now let's change the recipe and say include the recipe Redis IO default, right? So we're just going to go out and just run the default recipe. The way that this cookbook works is it just goes and installs Redis. Okay? So as I mentioned before, anytime we make a change to the cookbook, we have to reconverge the system, right? So we've told the system, I want you to be in a new state. Now we have to tell it, go and get into that state now. So we're going to run kitchen converge. Why? I guess it does want internet access. That's not good. 1 second. Wasn't supposed to do that, but okay. Sorry about that, everyone. I use the tethering just to make sure that it it has proper internet access. So let me just take a look. OK. Let's run that again. All right. So it needs to resolve the dependencies. And right. So now we start a chef run, and you can see right here, it's saying we're going to pull in the Redis IO Cookbook. And you can see right here, it managed to find Redis in temp Redis, and it's doing a compilation, right? So we're just using the existing code that somebody has shared on the internet for setting up and installing Redis. And as you can see, also the other nice thing that it does is it sets up an init service, right? So Redis will be there. So we've made our code changes. Let's verify that the tests are passing. And the tests are green. All right. So making sure that there's a user and that there's a directory is interesting, but not that interesting, right? We want to know, is Redis actually running? Can we do anything with it? So let's write some additional tests. So Redis, by default, listens on port 6379. 6379. So let's make sure that Redis is actually running and that it's listening on that port, right? So it should be listening. And let's also make sure that the service actually exists. So the way that the Redis IO Cookbook works is it names the service Redis and then followed by the port number, right? So we're just going to follow that convention. And we're going to say we expect it should be enabled, and it should be running, right? So we expect that Redis is running and listening on 6379, and that the service is there. And so when the system reboots, Redis actually comes back. So we've written some tests. Let's check, do they pass, yes or no? And oh, no, the tests aren't passing. So what happened? Well, you can see, again, this is the power of ServerSpec. It's using the underlying Linux netstat command to see, is that port being listened to, yes or no, right? And it's not. OK, well, that's not good. And you can see it's also using check config. So this is a CentOS thing, right? That's in Ubuntu. It's a different command. And that's the beauty of ServerSpec. Regardless of which operating system you're running these checks on, it knows which underlying commands to use. So on Windows, the netstat command, actually Windows does have netstat, but the service command would be something different, right? So let's make this test pass. So the Redis IO Cookbook actually has a handy recipe called enable. And that's really all we have to do. Just have to enable Redis. Right? So we have it installed already, but let's enable it. So as before, as soon as we make a change to the cookbook, we want to get the system back into the state we expect it to be in. So let's converge. And this time it should be actually really fast because we already have Redis there. And you can see right here, it just ran start. So ideally, this means it's passing. And again, we get that confidence by just running a kitchen verify. And voila. So Redis is running on port 6379. It's listening, and the service is there. All right, last example. We are talking about a database here, right? So databases are interesting when they can store data and you can get data back out of them, right? So let's make sure that the Redis that we set up can actually store data. So let's write some tests. So what I want to show you is that command resource in ServerSpec, which is your out. It's your way to execute any arbitrary command on the file system. So when Redis is installed, it actually comes with a handy tool called Redis CLI. Again, this is Redis-specific stuff, but it's pretty cool. And you can use it to set keys. So Redis is a key value store. You set keys, you get the keys back out. So we're going to set the key full stack TO to is awesome. Right? And we expect that command, so its exit status should equal 0, right? So we expect that command to pass, to work. And then the other command that we want to check is if we can get that data back out, right? So let's go to Redis, Redis CLI, get full stack TL. And we expect the standard output of that command should match is awesome, right? So again, it's a database. We expect the database to hold data and get data back out. So let's see. Is Redis actually running, and can we put data in and get data back out? We can. All right. Now, one last example. I had mentioned that you can run Test Kitchen with multiple platforms. So we've been doing this with CentOS. Let's say tomorrow your CIO says, hey, I heard about this amazing thing called Ubuntu server. We should definitely use it for everything. And you're like, oh, crap. All right, let's see. Does any of this stuff work on Ubuntu? Well, all you have to do is you come back here to your kitchen YAML. So this is your configuration for Test Kitchen. Instead of running on CentOS, we want to run on Ubuntu. And again, this is that custom Docker container that I had created with everything offline, which failed, but anyway. And we just say to use the Ubuntu one that I created. If you're just doing this at home, you can just use the Ubuntu Docker image that's already there, and all of this will still work. So your CIO comes, you say, okay, let's see. I don't know if it'll work, but let me just run my tests against it. And what you see happen is, oops, I think I have to converge. You see what Test Kitchen does in its output in the teal is CentOS, and in the yellow is actually Ubuntu. So we have to get the Ubuntu system into the state where Redis is installed and running, and then we can run our tests to make sure that it's passing. So you had a question, sorry.
Oh yeah, there was a quick question about when you were testing the setting and getting of the keys. Were you running that from your local machine or from the Docker image?
from the Docker image itself. So all of the server spec tests that I've been showing, those actually all execute within the Docker container. Yeah, and they're all the underlying shell commands. So like when we check user, it's ID, and those all run within the container. So you can see here the Redis IO is getting compiled on Ubuntu now, and then we'll see that, and you can see right here, right? Here's the difference. To do the compilation, we have to install build essentials, right? But you can see it's build essentials Debian. These are all Debian packages, right? And OK, that's passed. So ideally, we have now Redis running on Ubuntu server. And we'll know when we run our verification that in teal, OK, we already saw CentOS worked. But does this actually work on Ubuntu? And it does. Right? So this is the power of having tests, because you can do those transitions between platforms. You can really leverage your configuration management system. Did you have? So in Test Kitchen, this provisioner, you would change this provisioner to Ansible. Who would want to use this?
I'll give you an example. So like Ansible is open is like you find the state and you run it and then it makes it that way or verifies that it is that way. Anyway, so in theory, if I just run Ansible, if it completes no errors, then my system should be in the state that I said it should be,
right? Hey, I mean. Well, yeah, that's a good question. So kind of the level of tests that I had shown here are things like checking if the user is there. When you're doing this yourself, you probably wouldn't do that because you would expect your configuration management system to do that. However, there's also a gray area there. So writing the test indicates this is the state that I expect this cookbook or Ansible playbook to create. So if somebody later on who you're collaborating with comes in and removes that line that says create this user, well, guess what? The tests are going to fail now. And so they're going to say, oh, I guess that user should be there, even though they weren't really sure why. So it's the same thing as in writing software code. You write some software and you write the tests. I mean, you could say, well, my code says it should do this. So look, I accept these HTTP requests and I give these responses. But writing the tests gives you that regression bed that when somebody comes in and makes changes to that code, those tests might fail. And then you have some, oh, maybe it was expected to do that. Maybe it has this really weird use case that I want to make sure that user is there. So that's one reason why you might do this. But again, that's kind of a light one. I think the bigger and more interesting tests are things like these ones where you're checking, can I write data into the database? Is it running the way I expect? For example, in our Redis cookbook, the tests that we actually write are things like spin up a primary and replica and make sure I can write data to the primary, then read data from the replica, and also make sure I can't write data to the replica and that it fails. So things like, did everything wire up correctly? Kind of those higher level tests are probably the ones that you want to hit more than these lower level, like the user's there and it's listening on these ports and things like that. So other things like when we start up an application, we'll curl it. We'll curl the /health API and make sure, hey, did this app actually start up on the container as I expected it to? OK?
Do you have different scripts for different environments?
Yes. Oh, for different, what do you mean, environments?
So, for example, my environment is separated in that a test database, because of the way the firewalls are configured, cannot go into production.
Right.
So if you run a bunch of tests in UAT while the guys are testing, or
Right.
wherever they're testing, and then when you move that over to production, so you
Right.
I would still want to run set.
I will talk about that shortly. Yes. Okay. I'm gonna move on. So yeah, you've seen this. You can clap if you want for a demo passing. So we just saw I just wanted you to clap. we just saw this virtual cycle of writing a failing test, making it pass, and we didn't do any refactoring, but you could think of a refactoring as, hey, we dropped in Ubuntu instead of CentOS, right? Like we refactored our infrastructure to a different platform. So, of course, not everything is rosy, and there's always trade-offs with everything. So, one of the issues that you might run into is your tests might run slow. And now, this isn't so much the nature of ServerSpec itself, because the tests are really just execute these commands on the file system. But if the commands you're executing take a long time to run, well, your tests might take a long time to run. So in our case, we actually set up WebSphere, which is heavy and slow, and running WebSphere commands when you're doing a verification takes a really long time. So you can actually run into a slower feedback cycle of an hour or so to get that full test cycle. But as we discussed a bit with the question, you want to also write tests that are meaningful. So you want to write tests that target specific things that give you confidence in the system that you're setting up. And as with everything, adding testing to the cycle is additional process, additional overhead. And I think if you ask developers 10 years ago, when they started to practice testing in general, they'd say, oh man, I used to just write my code and we'd ship it and no one cared, and now I have to write tests. And but then 10 years later, they say, thank God I wrote tests, because now I go back to these legacy systems that have no tests, and I am scared out of my mind to change anything, right? So it adds more process, but it gives you that confidence. And really, I think you want to avoid the slowness issues, you really want to break up your configuration management code into smaller bite-sized chunks and target somewhere between 30 and 100 tests for each small component so that they run fast and you get a good feedback cycle. The other gotcha that you might run into is failing tests on Docker. So we use Docker here for a really good, for all of the performance benefits that you get. But Docker, because it's sharing the kernel with the underlying OS, there's certain features that are kind of restricted. So I've run into a number of issues actually running Docker inside of Docker, or actually NFS uses the kernel. There's a bunch of use cases there that interact with the Linux kernel that make your tests fail. Right, so in those cases, what I'd recommend is really just toss Docker out of there, drop in Vagrant, and your test will pass. Right, so that's really what we found. So 90% of our cookbooks run fine inside of Docker, and for the other 10%, we have to use Vagrant. So with all those issues in mind, at the end of the day, test-driven infrastructure is about safety and confidence. Right, so one story that I have is we ship our public website with the public website that the teachers interact with, and we use Chef to do that. We had an upcoming production release. You know, developers are making changes all the time, and they forgot to update the configuration for the production deployment. So there's configs for dev, there's configs for prod, there's a cookbook for dev, there's a cookbook for prod. The cookbook for prod failed, and we caught that early before it ever went to production, and brought down the website. So like these are kind of some of the things that you run into. And I mean, I have hundreds of stories. They're all kind of small things, but you just catch them. Oh yeah, okay, whoops, I forgot to do that. And it's not, oh, I deployed this. Oh crap, now the website's down. Okay, wait, what do I do? Try to go back, try to roll back, and et cetera. And the test-driven infrastructure, just like test-driven development, is all about moving fast and continuously delivering value, not downtime, right? So you really want to move fast, but you want to do it in a safe manner. So we've talked a lot about the local development workflow, but we don't all live in our mother's basement. Some of us do, that's cool, but we do collaborate with others usually. And how does test-driven infrastructure help with that collaboration? So this is where the CI system comes into play. So whether you're using Bamboo, Jenkins, Travis, whatever it is, using Docker really enables you to use that continuous integration environment to run those tests quickly, get that feedback fast, and minimal setup. So what does the full workflow look like? So on your workstation, you're going to be following the test-driven workflow. So you're going to write your failing test. You're going to make it pass. You're going to refactor. Then you're going to commit that change to GitHub, Subversion, whatever. That's going to trigger a build in your build system. And that build will spin up a Docker container, which will then run your Test Kitchen tests with ServerSpec. And if your test fails, well, that just goes back to you, and you get an email, you get a notification in IAM, you go fix it, and you go back through the cycle. But there's an interesting question. What happens when the build passes? And this is where a lot of the continuous integration systems have a continuous deployment part either bolted on or they come with it. And so this is where you could start leveraging that continuous delivery part of your CI system. And you could have a passing test automatically trigger a deployment to development, right? And if that's passing, you could theoretically, if you wanted to, also trigger an automatic deployment to production. And this is, the passing would really be, this is your continuous, this is your configuration management system passing, and the system should be up and running. I'll get to testing it afterwards as well. So this is the full workflow from your laptop or your desktop to production with a test-driven infrastructure approach. So what's the path ahead? One of the interesting features that's been coming recently is something called Chef Audit. This is Chef specific, but you can actually do this with ServerSpec as well. And Chef Audit mode is something that you can do after your cookbook or whatever finishes running. You can run a subset of your tests against that system after it's completed and gotten into that state, giving you that confidence that the Redis that you installed is running. You can write data to it. You can get data back out. And so you can actually, you can do this. I found out later that with ServerSpec, ServerSpec has an SSH driver, and you can actually tell it, go and SSH into these systems in dev. Go and SSH into these systems in prod and run my tests there. So that workflow might look something like this, right? So you saw, again, you have a successful build, which triggers a deployment, which runs your configuration management system, which completes. But then you run this audit mode or ServerSpec with SSH, and your test passes. So now you have the confidence, I deployed to dev, it converged. So OK, theoretically it's there, and my tests are passing too. So now I can move fast and hopefully not break things in development, in production. And finally, the last bit of things to consider going forward is multi-node testing. Right? So if you're setting up a Redis, or in our case, we set up the Logstash Elk stack, so Elasticsearch, Logstash, Kibana. Kind of, you have 6 or 7 different nodes all talking to each other, all on your workstation, configuring your entire multi-node infrastructure. So you can really start to get there. So if you take anything away, test your infrastructure and be a superhero. Thank you.